Welcome back to topic 44 for Algebra 2 on nth roots, radical expressions, and rational exponents. In part 2, we're going to practice more on simplifying rational exponents, including in a word problem, and also use nth roots to solve equations. So overall, with rational exponents, if we have c to the 1 over nth power, that's equivalent to the nth root of c. Now where did this 1 go? Remember, if we don't see an exponent, it's automatically a 1. So both the exponent of 1 over n and the radical symbol of the nth root indicate the principal nth root. Now in general, sometimes we don't have a numerator of 1 in our rational exponent. So the nth root of c is a real number, then the denominator becomes the index, and the numerator becomes the exponent. Now, what do I mean by this? So let's say we have c to the m over n instead of 1 over n. This is the same thing as the nth root of c raised to the mth power, which can also be written as the nth root of c to the m. Either way, I like to think that the numerator is already on top. It's already staying on top. Whereas the index is from the denominator. Kind of stays towards the bottom. Started from the bottom, now we're here. Now, what is the meaning of the exponent in the expression 27 to the 2/3 power? If we have 27 to the 2/3 power, that can be rewritten as 27 to the 1/3 squared. If we think back to our properties of exponents, a power raised to a power, we would multiply the exponents. We can rewrite that 27 to the 1/3 as the cube root, or the third root of 27 squared. Now what I want you to do here is think PEMDAS. So we're going to simplify in our parentheses first. The cube root of 27. What number times itself again, gets us 27? Well, that's 3. Now 3 squared, now that we think back to our exponent, the e part of PEMDAS, is 9. If we have 25 to the 1/2 power, we can rewrite that as the square root of 25. Because remember, if we don't see an index, it's 2. And if we don't see an exponent, it's 1. So there's the 1 that's the numerator and the 2 that's the denominator. The square root of 25 is 5. If we have 32 to the 2/5, this is the 5th root of 32 squared. Now in order to simplify this, what number times itself again, times itself again, times itself again gets you 32? X to the 5th gets you 32. So what should x be? Well, that is 2. But then we still have to square it. 2 squared gives us 4. Moving on to our word problem. The Fujita scale rating, F, of a tornado is represented by F equals the cube root of W divided by 14.1 squared minus 2, where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with an estimated wind speeds of 100 miles per hour? What we want to focus on here is the 100 miles per hour, because this is what W equals. So in our equation, wherever we see a W, we're going to plug in 100. This will give us F equals the cube root of 100 divided by 14.1 squared minus 2. Now this 2 is outside of our radical, so it's not included in the radicand. We can rewrite this it's already in radical form, we can write it in exponential form to be 100 divided by 14.1 to the 2/3 minus 2. Now what we're going to do is we can plug this into Desmos. So we have 100, let me get parentheses there just in case. 100 divided by 14.1, close my parentheses, raised to the 2/3 power. Don't forget to subtract 2, and we get 1.639, that should be 14.1, there we go. 1.69136779. So let's round it to the nearest thousands so we can be as precise as possible. This gives us 1.691. So the Fujita scale rate is 1.691 when we're dealing with wind speeds of 100 miles per hour. Now lastly, let's use nth roots to solve equations. If we have 2x to the 5th equals 64, what do we want to do right off the bat? Well, we want to solve for x, so we want to isolate it. So what I'm going to do first is divide both sides by 2. So I'm left with x squared equals 64 divided by 2, or 32. Now this x squared, x to the 5th, I'm sorry. Now this x to the 5th, in order to get rid of this 5th power, we can multiply, or I should say raise both sides to the 1/5 power. That will cancel out my exponents, and I'll just be left with x. So what is 32 to the 1/5 power? This will give us 2. Let's go to our next example. 5x cubed equals 320. What we're first going to do is divide both sides by 5 and get x cubed. Got that one this time. 320 divided by 5 is 64. Now, the same thing as raising both to the 1/3 power, the same thing is taking the cube root of both sides. But remember that property of equality. What you do to one side, you have to do the other. So the cube root of x cubed, those cancel each other out. So we're just going to be left with x. Now the cube root of 64 is 4. So x equals 4. Now lastly here's a concept summary. So it deals with both radical form, exponential form, and also solving an equation in the form of x to the n equals c, which we all just did. That was part 2 of topic 44 for Algebra 2 on nth roots, radical expressions, and rational exponents. Thank you for watching.